In today's technology landscape, clients expect a constant flow of updates. From microservices to mobile apps, modern applications have a lot of moving components required to deliver these services. The pipeline that keeps the updates flowing is continuous delivery, and optimizing time to market is what that makes it important. So hello everyone, this is Sahiti on behalf of Edureka, and I welcome you to this session on CI/CD pipeline. So thank you all the attendees for joining in today's session. Before we get started, all of you just give me a quick confirmation on the chat window whether I'm audible or not. Okay, I've got many yeses, so that's great. So now let's get started with the session. So moving on with the session, first let's look into the topics of today's session. We'll start today's session by understanding what is DevOps, and then we'll get into the terms CI and CD. After that, I'll brief you on what are pipelines, and I'll tell you what is the difference between continuous delivery and continuous deployment. After you understand the differences, I'll exactly tell you what do these two terms mean, and then I'll get into the role of Jenkins and Docker in CI/CD pipeline, and finally end this session with the hands-on part. Alright, so is the agenda clear to everyone? Okay, so that's great. So now let's get started with the session. So what is DevOps? DevOps is a software development approach which involves continuous development, continuous testing, continuous integration, continuous deployment, and continuous monitoring of the complete software throughout its complete development life cycle. So this process is adopted by almost all the top companies to develop high quality products with short development life cycles, resulting in great customer satisfaction. So now that you know that every company needs DevOps, let's understand the different stages involved in DevOps. Alright, so let's move on. So starting with version control system, version control maintains the code. Now what I mean by maintaining the code? Well, consider a scenario where there are multiple developers writing a code for a particular application. So how will I know that which developer has made what commit at what time, and exactly which commit is causing the error? And if I ever want to revert back to that particular commit, how do I go back and make changes? So basically, the complete concept relies on how I will manage the source code. So suppose developer A has made some commit, and that commit is causing some error. So how will I know that developer A has made that commit at what time, and what has he changed that is causing some error, so that I can revert back to that commit and make changes? So all these kind of questions can be answered when you use version control system or source code management with the help of tools like Git, Subversion, etc. After version control system, we have continuous integration. Continuous integration is basically building your application continuously. Now what I mean by building your application continuously? Now consider a scenario where a developer makes a change in the source code. Now, a continuous integration server should be able to pull that code and prepare a build. Now, when I talk about build is not just, compiling the code, but build also includes validating your source code, reviewing the code, performing unit testing, integration testing, and also even packaging your applications. So, when I talk about unit testing and integration testing, unit testing is basically testing each part, and integration testing is how different parts work together. So that's what integration testing is. After the stage of continuous integration, we have continuous delivery. So until now, your product is ready, it is tested, now it has to be delivered. So that's where continuous delivery comes. Now consider a continuous integration tool, let's say Jenkins. Now what Jenkins will do is, it will deploy onto the test servers to perform the user acceptance testing with the help of tools like Selenium. And once that is done, it will be deployed onto the prod servers for release. If this step is done automatically, then it is known as continuous deployment. But yes, if the step is done manually, if somebody has to approve it, then it is known as delivery. Now once your application is live, it is continuously monitored by the tools like Nagios, Splunk, which will provide the relevant feedback to the concerned teams. So once the teams get feedback, they take that feedback, they solve the bug, and then the product goes throughout the complete cycle again. Alright guys, so these were the stages of DevOps. Now let's go back and summarize all these stages again. So we have integration in the middle, that is using the Jenkins server. So any developer changes the source code, it will take that code and then it will trigger a build by using Maven, Ant or Gradle. Once that is done, it will test the source code in the test servers for end unit testing with the help of tools like Selenium or JUnit. And then what happens is it will automatically deploy the tested code right onto the prod servers for release. So to deploy the code onto the prod servers, we will use tools like Docker, Puppet, etc. And then after these stages are done, it will be continuously monitored with the help of tools like Nagios, Splunk, ELK Stack, etc. So you can see that DevOps itself has a lot of tools involved. So now it is really evident to your eyes that Jenkins is the heart of your life cycle, as it gives you the complete 360 view of the complete SDLC. So with this, let's understand what continuous integration is and continuous delivery. So continuous integration is like a software development life cycle. Now how does it work? So as you can see here, this pipeline is a logical demonstration of how a software will move along various phases or stages in this life cycle before it is delivered to the customer or before it is live. So just imagine you're going to build a website which is going to be deployed on the live web servers, and your product is a website or a web app. Now, you will have a set of developers who are responsible for writing the code which will further go and build the web app or website. So once the team of developers write this code and commit the code into the version control system like Git or SVN, it goes to this build phase. So this is the first phase of the pipeline where developers put in their code and code goes into the version control system having proper version tags. So you know which build has what kind of version tag. So any commit that happens and you find an error, you can just go to that particular version and then check the commit. So after you have your version control system phase done, then it goes through a build phase where you compile the code. So you get all the various features of that code from various branches of repositories. Then you merge them and then finally you have some compiler to compile it, and that is nothing but the build phase. So in build phase, what's happening is the code has been taken from the version control system and then it is compiled. So you know the code of all the features are merged and then it is compiled together. Once the build phase is done, you move on to the testing phase. So in testing phase, we have various kinds of testing depending on the type of the company or depending on the type of the product that the company is delivering. So one of the tests in the testing phase is unit tests. So what happens in unit tests is that you break your complete software into small little chunks. That is, the complete software is divided into chunks based on different parts. So every part has a code. So it is divided into small individual units to understand how it works, and when the test is completed, you have an assurance that that particular part is working. And once each and every part is tested, there is one more test that has to be performed, that is the integration testing. So what happens with integration testing is, now all these individually tested parts are integrated together and seen if they can work with each other or not. A software has many features where they have to work with each other. So that is tested in integration testing. After your testing phase is done, you next move on to the deploy phase, and this is the stage where you deploy your software onto the staging area or the test server where you're going to view the code. So in the deploy phase, the code is deployed successfully, and then you can run another set of sanity tests, and once you think that all the parts are working and everything is fine, you can finally think that it is acceptable, and then it is deployed onto the production stage, right? Meanwhile, in every step, if there's some error, development team fixes that particular bug and then pushes it into the version control system, which goes back to the complete pipeline again. So once again, if there is any error reported during testing, the feedback goes back to the dev team, they fix it, and that particular product goes to the complete pipeline again. That is, it again goes to the build phase, the testing phase, and then it is deployed onto the prod servers. So this is how in every phase, it moves on throughout the life cycle unless we get a code or a product which can be deployed into the production server, and there we can measure and validate that code. So pipeline is a logical step or a series of steps which define how software development lifecycle occurs. So guys, this was all about CI/CD pipeline. So now that you know a brief about all the stages in the CI/CD pipeline, let me tell you what exactly is continuous integration. So let's consider a scenario of a team which has 5 developers building a website which has many features. So let's say if this website to be a shopping website, right? So as we all know that in a shopping website, we have many pages like, the user details, the past orders, the shopping carts, whatever product a person has added to his cart and so on. And then finally, we also have the checkout page and so on, right? So all these different pages are known as features of the software. So when you have multiple features, you have to combine those features and merge them into a single version control system, where you merge the various feature branches of the code and make a single pool of the code which can be now comprising of all the features of various branches committed by the developers, and then you can build it as a product and move on to the testing phase. So what are you basically doing? You're combining all the feature branches, that is all the feature codes, into a single branch, and once you combine it successfully, so you're then moving it to the testing phase. Now, when you merge the code and you build the code to get a single unit of the software, this is nothing but integration. So, integrating means putting all the code together from all the contributing developers and then merging the code and building it as a whole. Now, you must be wondering, why do we call it as continuous integration? The reason is because everything happens in DevOps continuously. So everything is automatic. So as soon as the person commits the code in the version control system, it continuously starts merging the process, and then it continuously starts also building the process simultaneously. So that is the reason that it is known as continuous integration, as nobody has to wait for anything. After the stage of continuous integration, we have continuous delivery. So as and when we move on to the various stages in pipeline, we finally deliver the product, because as soon as it passes the test and new features become functional, it can be used as the final area for the product. So everything happens in a continuous way. So the product is built, the product is tested, the product is then deployed onto the prod servers. So since it is continuously integrated, built, tested and deployed and delivered, this process in short is known as the CI/CD process. Now once you have the continuous integration and continuous delivery in place, the deployable unit path is called pipeline. Now what do I mean by deployable unit path? I mean the path to the production servers where it is deployed onto the live servers. So now that you've understood what CI/CD pipeline is, let me show you a real life use case of a company known as Capital One. So Capital One is one of the well-known brands in America and is among the top 10 largest banks in the nations by deposits. It offers a wide range of financial products and services to commercial clients, small businesses, and individual consumers, both online and inline at branch locations. The company was founded on the vision that the power of IT and testing could be harnessed to bring the highly customized financial products directly to the customers. Now, the initial challenge was to increase the automation while ensuring stability, scalability, and security. As continuous integration practices were becoming increasingly mainstream, Capital One formed a continuous delivery tools team as a part of restructuring the company's technical organization. So this team was created to support thousands of developers by providing a solid service that helps them deliver software applications more quickly and in a more agile fashion. From a platform perspective, the technical makeup had to be extremely flexible to meet a wide variety of use cases, but it also had to be both stable and scalable. Further, as financial services company, Capital One needed its platform to be secure itself and promote improved security for the applications built with it. So, with these objectives in mind, the new shared continuous delivery tools team sought to implement the CI/CD practices that supported security practices without stifling developer innovation with reference to speed and security. So, the solution they found out was to establish a platform for CI/CD to deliver quality software with shorter time to market. So, how did they do that? So, the shared continuous delivery tools team established an internal platform for automating builds, testing, and deployments based on cloud-based Jenkins platform. They used the role-based access control plugin to implement an authorization strategy in which security roles were assigned to a group of users. After the initial platform rollout, the team made incremental refinements over the time to improve operational efficiency. They decoupled their Jenkins agents from masters, giving them the ability to scale masters and agents independently using the Amazon Web Services. The team began using cloud-based Jenkins Operations Center to manage multiple masters and reduce the administrative time by ensuring plugin compliance and version consistency with the update centers. So the team settled on a single default environment for all the groups. On the top of the infrastructure created by the team, a common implementation pipeline layer was also created. So this is how they used the CI/CD pipeline, to solve their challenges. So after implementing the CI/CD pipeline, they saw that 90% of the pipeline was automated. So this increased the deployment frequency with 1300%. So that's a huge number, isn't it? So with the Jenkins platform, they created a service for the developers that was scalable and stable. As a result of this, the time that developers would have spent managing the infrastructure was now spent by developing business applications. And obviously, as I said, this increased the deployment frequency by year on year, right? And also, it was seen that the quality and the security of all the repeatable processes was ensured. So they implemented consistent repeatable processes in an automated fashion every time a developer wanted to commit or every time a developer wanted to deploy something. So this produced a more secure software, enabling them to deliver it faster. So guys, that was the use case about Capital One. So it was really clear to you, right, how they faced the challenges, they solved the problems with the help of CI/CD, and they could clearly see evident results. So in between the discussion, you must have also observed that I was mentioning Jenkins platform, right? So why do you think that they just used Jenkins? Why not anything else? So why do you think that Capital One went for Jenkins platform? Why was it so important to them? So let's understand what Jenkins is and let's understand the importance of Jenkins. So Jenkins is an open source automation tool written in Java with plugins built for continuous integration purpose. Now consider that you have to automate the entire process, that is from the time the development team gives the code to the time that code is deployed onto the production servers. So that there are various steps in the pipeline and you have to automate this pipeline. So how will you do it? So in order to make the entire software development lifecycle on the DevOps mode or the automated mode, we would need automation tools. So Jenkins is a really good automation tool that you can use. Now how is Jenkins going to help us? So let's know. So Jenkins provides us various interfaces and tools in order to automate the entire process. By entire process, I mean the process of the complete development lifecycle. So what happens is that, so suppose you have a Git repository where the development team commits the code and then Jenkins takes over from there. So Jenkins will pull that code and then it will move it to the commit phase where the code is committed to every branch. Then Jenkins moves it and then it goes to the build phase where it will compile the code. Now after the code is compiled and after the code is validated and reviewed, the code is tested, and once all the tests are done, it is finally packaged into an application. It could be either a WAR file or a jar file. So what Jenkins does is it is going to pull your code from your version control system and then it is going to perform the build. It is going to compile your code. It's going to validate your code. It's going to again review the complete code. After that is done, it will perform the unit testing and the integration testing, and then finally it will package your application into a WAR file or a jar file, and then it is ready to be delivered. So that's what Jenkins helps us to do. So now you must have understood that this is the tool for basic continuous integration. But as I just said, Jenkins' role is only till the application is packaged. Now if it has to be delivered, then we need some tools to deliver that product, right? So once the product or the software moves on to the staging server, to deploy it, we need tools like Docker. Now what is Docker? So Docker is like a virtualization environment which we can create on the fly. So it just takes few seconds to create an entire server and deploy something on it. So to deploy some software, we will need an environment which will replicate the production environment, and that's what Docker provides. So Docker is not exactly a virtual machine, but it can create images like a virtual machine, and then it can run as a container which will completely replicate a particular platform or an environment where you can deploy your artifacts or jar files or any other kinds of files, and then you can test those files. So now that you know a lot of theory about CI/CD pipeline and you know the tools for CI/CD pipeline, that is Jenkins and Docker, let me show you practically how a CI/CD pipeline is created and how it is executed, right? So let's get started with our hands-on. So we're going to build a CI/CD pipeline using Jenkins and Docker. So for that, let me just open my VirtualBox Manager where I've installed Jenkins in my system. If you want to know how to install Jenkins, then you can refer to our video of Jenkins installation. Let's go to my VirtualBox. Before I start creating my pipeline, let me run the Jenkins service and Docker, right? So let me open the terminal. Let me enable the Jenkins service and the Docker service before creating the pipeline. So let me type in the command. So for that, I'll type in systemctl start Jenkins. So it will ask me my authentication. So I'll type in my password and then I'll type in systemctl enable Jenkins. So as you can see that I've not got the privileges because I've not entered the command as the super user. So if you wish to enter the command as the super user, you have to type in sudo before the command. So you'll type in sudo systemctl enable Jenkins. And then you'll be asked for the password. So let me type in my password. And then you can see that your Jenkins server has been enabled. Now we also want Docker to run. So for that, we'll type in systemctl start Docker. Again, it's asking my authentication. So I'll type in my password. And then Docker has started. So our Jenkins service and Docker has been started. So now let's open our Jenkins dashboard. So for that, I'll open my local host. So let me open my Jenkins dashboard. So when you open your Jenkins dashboard, Jenkins always asks for the user ID and the password. Mention your user ID and the password and click on login. Alright, so this is your Jenkins dashboard. Now what I'm going to do is I'm going to create a pipeline. So for that, I'll be using 3 jobs. The first job would be to build the project. The second job would be to test the project. And the third job would be to finally deploy the project. So for that, we'll be creating 3 jobs. So let me show you how to create new jobs. So for that, you have to go to new item. You have to type in the job names. So let me put in the job name as job 1 and choose as freestyle project and then click on OK. Once this is done, I'll again go back to my dashboard and create 2 more jobs similarly, that is job 2 and job 3. So let me type in the name job 2 and choose it as freestyle project and click on OK. And when it comes to the configuration part, I'll tell you what you have to configure soon. And then similarly, I'll create a new job, that is job 3. So let's go back to our dashboard. So you can see that 3 jobs have been created. Now I want to create a pipeline. So what I'll be doing for this pipeline is I'll be pulling a code from a Git repository, and that code is a Java web code which is basically given to the development team for the testing. So that is job 2 here. And once the testing is done, it will be deployed. So for that, you have to mention the repository's URL in your job to pull that code. So let's mention the repository's URL. So for that, I'll go to job 1, I'll go to configure, and then I'll go to the source code management tab. I'll go to Git because I'm going to mention the repository URL of a GitHub account. So I'll mention the repository's URL. So this repository has all the files related to the project. So this is where from Jenkins will pull the code and then it will perform the build, test and deploy operations in a CI/CD pipeline. So I'll click on this and save and apply. Similarly, I'm going to do it for the other 2 jobs also. So we have mentioned our Git repository for all the 3 jobs. Now we have to configure our jobs in such a way that when it performs the build option, it knows what code it has to compile and what all has to be installed respectively. So after mentioning your GitHub repository URLs for all the 3 jobs, our first step is to build the source code to get a WAR file, that is an executable file. Now what does this mean? Basically, when the Jenkins server pulls the code from the Git repository, it uses Maven to install that package. So for that, we have to mention the command of maven install, and then maven install installs all the dependencies that are required to compile this application. And once the application passes all the tests successfully, it will then use Docker to deploy it. So this is the process of the CI/CD pipeline that we're going to use. So for that, let's go to our job one and then configure it first. So let me open my job one, go to the configure option, go to the build option here, go to add build step, choose execute shell because we're going to execute the shell commands, and then I'll mention the required commands. So the required commands would be here to mention the directory of our web code and then also mention maven install. So because we want to install all the dependencies required to compile our project. So let me mention the commands. So as you can see that I've mentioned the required commands. So our first command is to change the directory of our web code. That is the directory in which we want the code to work in. And then we are using the command maven install to install all the dependencies required to compile the code. After that, we want it to move on to the testing phase so that the testing is performed. So we're going to change the directory to the testing phase, and then we will verify the testing results with the help of this command. So this is what you have to mention in job one. After you've mentioned this, you can then save this job one. After that, let's configure job two. Job 2 is where we want the testing to be done, and then we want it to be copied to the Docker file so that our application is deployed onto the prod servers. So for that, I'll go again onto the option of configure, and then I'll go to the build option. I'll go to add build step. I'll choose execute shell, and then I'll mention the required code. So after our job 1 has been built and tested, we want our application to be deployed onto the prod servers. So for that, we'll build a Docker container. So to do that, you'll use the commands to change the directory as cd java web code, and then to build a Docker container, you will use the command docker build -t DevOps pipeline demo. So that is the name I've given. You can give any other name that you want. After that, you can click on save and apply. Once this is done, let's configure job 3. That is our final stage where everything is tested, and then we just want it to be deployed onto the prod servers. But before that is done, we have to check one thing, and that is if our image has been created previously or not. If there is an image that is previously created, then we have to remove that old files. Else, if it is not created, then we can say that a new image has been created. Or if you say that there is no container existing at all, then you can reply a message that there is no container existing, right? So for that, let me just go to the build option again, go to add build step, go to execute shell, and then I'll mention the commands. Alright, so I've mentioned the required commands. So my container that I've previously created on job 2, that is DevOps pipeline demo, is running. And then over here, I'll check if it is previously existing or not. If it is existing, then I'll remove the files by using the command rm, and if it is not, then I'll print a message saying that the container does not exist. So that's how you can make sure that your container is previously existing or not. After you're done with this, you can just save and apply. So now that I've told you that we are creating a pipeline, that means all the jobs must be interconnected. So the pipeline should know after job 1 is built, what has to be built next, and after job 2 is built, what has to be built next. So to do that, we have to mention in the configure options of jobs. So let's go to the first job, that is job 1. Go to the configure option, and over here, I'll go to the post build actions tab, and over here, I'll choose build other projects. So I'll mention the next job that has to be built after job 1, that is job 2, right? So I'll mention job 2, and then I'll save and apply. After this is done, I'll go back to my Jenkins dashboard, and I'll go to job 2 over here. I'll then configure job 2, and then I'll mention after job 2 is built, what has to be built, that is job 3. So I'll again go to the post build actions, go to the build other projects option, and then I'll mention job 3 here. So we have mentioned our post build actions. So now what will happen is once job 1 has been successfully built, it will automatically start building job 2, and once that is done, it will automatically start building job 3. So that's how you can build various jobs one after the other. So as I said that we're going to create a pipeline. So to create a pipeline, you have to go to this plus option here. You have to mention your view name. So that is your pipeline's name. So suppose I mention it as DevOps pipeline. So let me mention the name. And then I'll click on build pipeline view. And then I'll click on OK. Now, once this is done, as I said, a pipeline should know from where it should start. So we're going to mention job 1. So that is where our pipeline will start. So I'll go to the pipeline flow section and then I'll mention the initial job as job 1. So that is already mentioned here, and once that is done, I'll click on apply and then click on OK. So that means our pipeline has been built. Now, if you have to run this pipeline, you just have to go to this option and run. So you can see that if the job 1 is in yellow, that means it has started running, and job 2 and job 3 are in the sequence. So as you can see that job 1 has been successfully built. So let me open my console output and show you. So you can see that our Git repository has been pulled. So the code has been compiled. All the Maven dependencies are installed that are required for compiling the application. And finally, we can see that our test results have been successful. In the second job, we were creating a Docker container. So let it run. So let me show you how the Docker container was created. Alright, so you can see that our job 2 has also successfully built. So you can see that all the artifacts have been copied and the Docker container has been created. So our job 2 was also successful in building. So let's wait for the job 3, and once it builds, I'll show you that it has been deployed successfully. Alright, so you can see that our job 3 has been successfully built. So that means that our CI/CD pipeline was successful. So before I move on to show you the output, let me show you the console output of job 3. And you can see that yes, our container did not exist previously and a new container was created, right? So guys, that's how you build the CI/CD pipeline. Now let me show you the results. So I'll go to my local host. So you can see that our application is running fine. So guys, that's how you can build a project and then compile the code by installing the required dependencies. And once that is done, you can push it to the test phase where the product is tested. And once it passes all the tests, it is then deployed using the Docker image. And once that is also successful, it is deployed onto the production that you can see in front of your screen. So guys, this was a short demo on CI/CD pipeline. I hope you found this video informative. Thank you and have a great day.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!